cos hyperbolic 2y, you have to use this relation e to the power 2y plus e to the power minus 2y by 2. So that means e to the power 2y plus e to the power minus of 2y actually can be replaced by 2 cos h 2y. Okay, so I'm just going to do it now. Okay, and let's just try. So I'm just going to modify your, okay, so these are the answers that you have given, so chances are that all three of them may not be correct. Okay, let's just check. So I will just replace it. Okay, this is u plus v, this can be written as 2 times sine of 2x divided by this plus this can be written as 2 times cos of hyperbolic 2y. You can just check it step by step, you've already done it. 2 cos 2x. Okay, so this is in fact a complicated problem. Okay, so maybe I'll just get rid of these 2's. Okay, so I'll just write it down as sine of 2x divided by cos hyperbolic 2y minus cos 2x. So yeah, that's my fz, right? So we'll just take it, fz is equal to u plus iv, and then fz I is equal to, I'll just repeat it anyway, iu minus v, add them up, get your function fz is equal to capital U plus, right, I capital V. Right, so we have this. Now we are going to use it, right? And given is this time you are not given u. Okay, you are given v. Check this, u minus v, u plus v is this is u plus v. Okay, if you check the item, so this is u plus v. So the first thing you have to note is you are given v and not u. So v is equal to sine of 2x divided by cos hyperbolic 2y minus cos of 2x. Okay, so that means if I use the Milne Thompson method now, the first function would be del v del y, and this is the first thing, or this is the probably the first mistake for some of you which you might do. So del v del y would be the first function and not del v del x. So you do it this way, you can take it to be sine 2x divided by, so you can use substitution method, you can put this as k. Okay, and I hope all of you remember this, right? So you can just take this, or maybe I can do it, right? So if I'll do just one step here, k is equal to, let's say, cos of hyperbolic 2y minus cos of 2x. Sine is there, let me not consider this. So that means I can take del k of 1 by k, but k was not the original variable, so I'll just write it down as del k del y, right? So del k of 1 by k is 1 divided by k square, and del y of k, so k is cos hyperbolic 2y minus cos of 2x, right? So you can always do the substitution method and do it easily. Okay, please make sure that all of you are doing it. Okay, so nx to minus 1. Okay, so anyway, and this will be 1 divided by k square minus 1 divided by k square into del y of this cos. Okay, and that will be a minus sign again. Okay, this will be minus, and 2 times sine of, should be able to do it by substitution method. इसको अंदर ले लेते हैं, नीचे इसको भी. Okay, so do it this way, and then you should get your answer something like this, k square. So k square means cos of hyperbolic 2y minus cos of 2x whole square, okay, into 2 times sine hyperbolic 2y, right? So if you just do it del v del y, you should get 0, right? So मेहनत बहुत किया है हम लोगों ने, but ultimately you're going to get 0 only, because phi z 0 and you put the value of y as 0 and sine hyperbolic 0 would give you 0, so everything will become 0. So ये हो गया. Then we have to find out what is my del v del x, right? Now this will be a bit long, and then you have to do it carefully, because there is an x at the numerator, there is an x at the denominator. You have to do it carefully, right? So let's just do it. Let's try del v del x Okay, just need to be a bit arranged. Okay, I don't think I can arrange it properly here. Less space of sine of 2x, right? So what you can do is we can actually, take two functions. One will be sine 2x, and then I can just simply, take the other term to be 1 divided by, let's say write down k. Okay, I'll just not going to repeat this again and again. Then plus del x of 1 by k is this, into sine of 2x, right? And then you can do it, I think it's not complicated, you just do this one. This would be 2 cos 2x, okay, in divided by k. For us k is this, okay, but anyway I'm going to write it down finally, minus, and here also you can do the same thing, okay, del x of 1 by k, and you can just take this and you'll be getting a minus sign because you are taking with respect to x. This is minus cos 2x, so you do it. If you do it, you are going to get this. Check this, okay, this is something which you must check. If you do it, you should get sine of 2x, which is already there, okay, divided by, and that will be the k square term. Let's say I write down k square only directly, and then you should get only for the cos 2x term. If you do it for cos 2x term, you'll get 2 sine 2x. Similar to this, okay, just do it, you're going to get this, okay. So that means my del v del y is equal to, maybe I can take it here, k into 2 times cos of 2x minus sine of 2x into, right, so this is sine 2x, this is sine 2x, so we can take square of this, and 2 times this is 2x, this is also sine 2x, so 2x sine 2x square divided by into 2, and then divided by k square. You just take the LCM, okay, you should get 1k here, so that is 1k, and then LCM is k square, and that's it, right? So if we just now expand it, okay, that means the final expression should be this. What is my k? K is cos hyperbolic 2y minus cos of 2x minus 2 sine square 2x divided by cos hyperbolic 2y minus cos 2x. So you should get this, okay. So that means from here, if we just want to find out what is my phi 2 z0, let's just replace it fast, okay. This is 0, so cos 0 hyperbolic 0 is again 1, minus cos of 2, in place of x we are going to write down z, minus 2 times sine square 2z, 2 in place of x we are going to write down z, divided by cos of 0 y 0, so sine hyperbolic 0 is 1, minus cos of 2z whole square, right? So there is a whole square there, sorry, mistake, right? So we can simplify this. I think this is cos of 2z, and did I miss out anything? Okay, sorry, this term was there, right? 2 cos 2x, sorry, missed out there. This is here, 2 cos 2x. I have already written k. 2 cos 2x is here, so that means there will be a term here, 2 cos 2z, right? It will be 2 cos 2z. So you can open the bracket and you see you will be getting 2 cos 2z, 2 cos 2z, and then this will be minus, and this is 2 cos square 2z, and this is minus 2 sine square 2z, right? So cos square plus sine square is 1, so if you take common, and then you will get 1 is left out with 2. Open the bracket, do it, you should get it. Very preliminary, I should not do it here. Cos of 2z whole square. So this is my phi 2z. So I got phi 1z and I got phi 2z. Let's proceed, right? Is 0, and phi 2z0 is equal to 2 cos 2z minus 2 divided by 1 minus cos of 2z whole square. So that's it, right? So if I just put the values and all, we get this. And here, okay, you can simplify it further. We can take 2 common, cos 2z minus 1, and this is 1 minus cos 2z. So you can take common cos of 2z minus 1. It's a square term, so I can reverse. I can also write it down as cos 2z minus 1. It's the same thing, square. So one term gets cancelled, it gets even more simplified. So once you get this, I'm sure that you're going to get your answer. So the only mistake that you can do in these kind of problem is probably you have not arrived at this phi 2z correctly. That's the only thing we need to do, right? So that means fz is equal to integration of phi 1 z0, so that's 0, plus phi 2 z0, that means this is 2 times I into phi 2 z0. Okay, this is v. So v means it will be phi 1 z0 plus I times phi 2 z0. Okay, plus, it's not a minus, so it will be plus 2I divided by 1 minus cos 2z, or 2 cos 2z minus 1, same thing, just take it anyway. So cos of 2z minus 1, take it, and this will be dz plus c. So you should be getting your answer now. So 1 plus I f z is equal to this 0, so I will take 2I, right, and this will be dz. I just check this, okay. I think did some mistake here. Just check it once. Cos 2z minus 1, this is 1 minus cos 2z, I can take it as a minus. Okay, so cos 2z minus 1 can be written as 2 cos square z, okay. Maybe I can write it down as 2 cos square z dz plus c, okay. So I can do it anyway. Okay, anyway, now I'm getting a different answer here. I'm getting in terms of sign. This is 1 minus cos 2z whole square, and if I take 2 common, this would be minus, okay. Actually, we can do it both ways, doesn't matter. I can also write it down as minus of 2 divided by 1 minus cos 2z, and that way, if I write it down here, maybe I'll put a minus sign here, okay. You can do it anyway, like minus, and then 1 minus cos of 2z, take a minus here, this would be 2 sine square z plus c, so this would be minus of 2I, so 2 will get cancelled obviously, so it will be just minus of I, and dz divided by sine square z is nothing but cos x square z, right? And if you take the integration of cos x square z, it should be cot z, so it should be cot z plus c. So fz can be minus I divided by 1 plus I. Please check with what you have done so that get the correct answer, all of us. Cot z plus c by 1 plus I, just write it in as k. Okay, so this should be the solution for this. Hopefully I have not done any mistake. I think it looks correct to me. Okay, all of you please check the answers that all of you have given. I think this is the nearest answer.
Hello, sir.
Yeah, tell me.
Sir, the sign will be positive now in the answer.
Let me check. Answer. Okay, I divided by 1 plus I into cot of z plus k. Okay.
Hello, sir.
Yeah.
I got the same. Can you show me the previous slide, because
Yeah,
I
check
got.
this. So I'd suggest all of you to check this slide and see where you have done the mistake. Okay, and then probably you should get it correctly.
So actually, by putting
Sir,
the value of z, I actually did the mistake. That's why
Okay.
my answer was wrong.
sir, I got the same answer, but there is some extra thing in my answer.
Okay, extra.
I
What is extra in your answer? Just check.
plus iota upon 1 minus cos 2z.
Okay, so okay, you're getting a cos 2z term there, but we have done the calculation here. It doesn't seem like there should be a cos 2z